The more I think back on the previous videos, the more I realize that probably the easiest way to do this is the second example of guess and check, the one that I just did in the video just prior to this. Uh, the reason why I thought before to do it a different way was because it comes about more naturally from what you're doing whenever you're factoring, and that is you're undoing distribution more or less. And that leads us into factoring by grouping, because this is something that comes very naturally out of the realization of what it is that we're doing whenever we're factoring. So the best way to understand what factoring by grouping is to first see it done in action. So let's have this example, and after we do it in action, we'll see exactly how to do it. But so let's take this first example. We have 2x squared plus 11x plus 12. Okay, so we can rewrite this as 2x squared plus 3x plus 8x plus 12. See, all I did here was I separated this 11x into 3x plus 8. And you might think, well, why on earth did you do that? Well, actually, it's not that hard to see, because now we can factor out this x from here. See, we have a common factor to these two terms. So let's go ahead and factor out the x from these two terms. I'll put parentheses here just so you can kind of see that this is, you can factor an x out here. So you can have x 2x plus 3. So I just pulled out the x that's common to both of them. I just factored it out, and then I can factor out a 4 from these two terms. So we'll have plus 4, and then we'll have left over 2x plus 3. So notice something pretty important now. We have a 2x plus 3 common to both of these terms. So let's find a new variable. We'll say a equals 2x plus 3. We're defining a this way. So, and you don't need to define a every time you do factoring by grouping. I just wanted to do it so you understand exactly what I'm doing here. So then we have xa plus 4a. And now what do we have? We have that a is common to both terms, just like 2x plus 3 is common to both terms. But what does it mean whenever you have something that's common to both terms? You can factor it out. So we'll have a times x plus 4. But we already know what a is. A is going to be 2x plus 3, and then we'll still have the x plus 4 left over. And you can you can skip directly from, like you can just skip this line altogether and go straight from here to here, because you can just kind of see that the 2x plus 3 is a common factor to both of them. So let's go ahead. And so the thing here is you can see that works pretty in a pretty elegant way almost. But there's one trick to it. How did I know that this was going to be 3x and 8x? How did I know it wasn't going to be 4x and 7x? Or 5x and 6x? How did I know that that's what the two are going to have? Well, to understand that, we're going to need to do a little bit of kind of abstract stuff. In particular, we're going to be doing, as always, like we do with a lot of factoring, we're going to go in the reverse direction. So let's deal with mx plus n times px plus q. So let's get rid of that. So we're going to go ahead and work backwards with this. So let's notice something, that this, whenever we distribute this using the FOIL mnemonic, what that technically is a shortcut, because to do factoring completely properly, and obviously you don't need to do this, but it's important for this explanation. We would first take this entire thing, this mx plus n, and distribute it to the px, and then to the q. And that's what we're going to do. That's what we're going to do right now. So we'll have mx plus n times px plus mx plus n times q. So all I did here was I distributed the mx plus n to the px and the q. And let's go ahead and put in equals. And the reason why that's important will become, well, you can kind of see that this is, you can see how we're going in the reverse direction of factoring by grouping, because this part is very similar to this part. So again, we'll be going in the reverse direction. But let's go ahead and finish distributing these individual terms, and we'll see how you get to the end here. So this px distributes to the mx. So we'll have mpx squared. This is just from distributing the px to the mx, and then we'll do it to the n. So plus npx, and then the q to the mx, so we'll have plus mqx, and then n to the q, plus nq. And then we can combine these two terms to get mpx squared plus np plus mqx plus nq. So you can see factoring by grouping in reverse order. See, first we figured out how to separate the middle term, how to separate b, because remember this isn't going to be, this is now in the form ax squared plus bx plus c. So np plus mq is equal to b, and mp is equal to a, and nq is equal to c. So you can see how this is going in the reverse order. First you find out how to separate np and mq, then you do it, and then you can factor out. So the trick here then is to figure out what are np and mq. So we know that np and mq, when you add them together, is going to equal b. Now let's do something different. Instead of adding them together, let's multiply them together. So we'll have np times mq. Well, remember that whenever you're multiplying four things together like this, you can just rearrange them in any order you want to. So let's go ahead and say that this is mp nq. I just put the n over here, the m at the front, the q at the end, blah blah blah. I just rearranged it. It's the same letters, just rearranged. And then notice that this, that's not big enough. Then notice that this I just put parentheses around the individual, around these two things. But what is MP? MP is A. What is NQ? NQ is C. So that means that to find NP plus MQ, or to find, we know what NP plus MQ is, to find what those two things are, what you want to separate them to be, you're going to find out what two things multiply to make A times C, but add to make B. So, to go back to the previous example, you'll excuse me if I scroll without clearing this off. So to go back up to this previous example, I'll write this up here. So we have 2x squared plus 11x plus 12. Okay, so now let's get this in a place where you can see everything. So we know that NP plus MQ equals B. We want to find out what NP plus MQ is. Remember, the reason why is because we want to find, here is NPX plus MQX. That is necessary to do the factoring by grouping. Like here's the NP, 3 is NP in this case, and MQ is 8. So let's get rid of that because we don't need it. But so now we want to find out what two numbers multiply to make AC and add to make B. Well, AC is equal to 2 times 12 is 24. And B, of course, is equal to 11. So we need two numbers that multiply to make 24 and add to make 11. So let's try 6 and 4. 6 and 4 multiply to make 24. Do they add to make 11? Well, no. 6 plus 4 is 10. So let's try 8 and 3. 8 and 3 multiply to make 24. They add to make 11. So 8 and 3 look like there are NP and MQ. Add them together, and you'll get 11. So 8 plus 3 equals 11. Multiply them together, and you'll get 24, which is A times C. So now we can go ahead and, now that we know what the two numbers are, we can factor by grouping. So I'll write that over here. 8 and 3. Oops. Okay, I had to. 8 and 3. Okay, now let's clear this stuff off. Okay, so 8 and 3 are our two numbers. So we want to separate this 11 into 8 and 3. So 2x squared plus 8x plus 3x plus 12. So now we can factor something out of this expression and out of this expression. So the thing that we can factor out of this is going to be a 2x, because 2x is common to both of these. You can do this individually with doing the 2x squared and 8x. I'm not going to do that. I can just kind of see pretty clearly that's going to be 2x. So we're going to have x plus 4 left over. We can factor a 3 out of this. So we'll have 3x plus 4 left over. Now we have an x plus 4 common to both terms. So we can say that this is equal to 2x plus 3, x plus 4. And let's look up at the top. If you'll excuse me again that I do this without clearing it off. And we get the same answer. We get 2x plus 3 times x plus 4. So that is how we factor by grouping. I know that probably seems very abstract, but we'll go ahead and do some examples in the next video, and you will hopefully get the hang of it, and I will see you there.